All right, so EG11A, evaluate inverse sine of negative root 3 on 2. So if I did a negative sine graph, and you really sort of have to know what your graphs look like. So remember, they go between negative 1 and 1, so an inverse sine. It starts down here, okay, and it will come sort of slightly curving this way and up like that. Now again, if you're not sure, you just imagine sine is on the y-axis and sort of doing that. And that's sort of like an easy way to get the shapes. Okay, and we know that this value down here is minus pi on 2, and this value here is pi on 2. So this question's saying, so this is y equals sine to the minus 1 of x. So the question's really saying where on that graph to get a value of minus root 3 on 2. So if we want the inverse sine of negative root 3 on 2, okay, there's some, well, what's the angle? So there's negative root 3 on 2. Root 3 is about, 1.7, so half of 1.7 is about, 0.85, so sort of, it's down there. And you can see you're going to get a negative answer, okay? So we can sort of, this is negative root 3 on 2, roughly there. All right, so how do we do an inverse sine of negative root 3 on 2? Well, if we did just draw out our standard triangle, 2, 1, root 3, 2, 1, root 3, we're going to do sine to the minus 1 of positive root 3 on 2. And we know the opposite has to be root 3, so we're talking about that angle that's pi on 3. So that's equal to pi on 3. So where is sine negative? Well, sine's negative in the third and fourth quadrant, but we want it on the domain that we need. So we need the domain, we need sort of our values to be between minus pi on 2 and pi on 2. So the only value that's going to be valid there is if you go in the negative direction. So if you had your unit circle and you went down there, you would go minus pi on 3. You could say 5 pi on 3, but that's not in our domain. So our domain that we have is minus pi on 3. So our answer for this is sine to the minus 1 of negative root 3 on 2 will be equal to minus pi on 3. Okay, so that's A. I'm going to struggle to fit this in on the screen, so let's do B. So inverse sine, now these are easy, but they're not. It's a bit contradiction, isn't it? So I don't care what sine of pi on 6 is. Okay, I know that sine of pi on 6 is a half. Okay, well then do the inverse sine of that. Well, inverse sine of a half, but you've got to make sure it's over the domain that's valid for the inverse sine graph. So if you do the sine of a number and then do the inverse sine, well, you've just got the number that you started with, and provided it's in the domain, then you're fine. So for BI, it's just pi on 6. For II, we do sine to the minus 1 of sine of 5 pi on 6. Well, think where 5 pi on 6 is. Second quadrant, isn't it? The sine of it's, the vertical one. So that's 5 pi on 6. So the sine of 5 pi on 6 has to be the same as sine of pi on 6. Sine of pi on 6 is a half. Do the inverse sine, and you'll be back where you started with. Now, you can't just say it's 5 pi on 6, because 5 pi on 6 is not part of your domain. So you're going to say, well, what is part of my domain that still has the same, that still gives me the same result? And of course, your answer is pi on 6. Okay. Part 3, III, sine to the minus 1 of cos of pi on 3. And again, just got to make sure it's in the right domain for sine to the minus 1. So if I did cos of pi on 3, well, that's actually the same as sine of pi on 6. So this really is the same as part I. So this is the same as this. So the sine of, if you do take pi on 6 and do the sine and then do the inverse sine, you haven't done anything. So it's just pi on 6. You'll spend a fair bit of time thinking about these, but once you've got it, then it should be right. All right, so let's do this last one. Sine of cos to the minus 1 of 1 on root 2. Okay, well, the nice thing about this one is cos to the minus 1 of 1 on root 2 is obviously, that's 45 degrees. So that's actually the same as sine of sine to the minus 1 of 1 on root 2. So if you take 1 on root 2 and do the inverse sine of it and then do the sine of it, you haven't done anything to it all. So it's just going to be equal to 1 on root 2. Okay.